For our math warm-up today, I would like you to go ahead and take out a whiteboard or a piece of paper, number it from 1 to 4, and you're going to look at each one of these inequalities and determine whether the inequality is true or false. Pause your video now and come back when you have finished. So let's check to see how you did. So 0 and 5 tenths is greater than 0 and 49 hundredths is true. 12 and 35 hundredths is less than 12 and 4 tenths is also true. 6 and 785 thousandths is greater than 6 and 79 hundredths is false. And 5 and 289 thousandths is less than 5 and 3 tenths, which is true. How'd you do? For our math message today, you're going to take out a sheet of paper, and I would like you to fold and shade it to find 2/3 of 2/3. Pause your video and do that now, please. Okay, so let's take a look. I first folded my paper along the horizontal lines here to break it into 2/3 or 3/3. And then I folded along the vertical line to show 2/3 of 2/3. So originally I shaded all of this area green to show 2/3. Then we had to find 2/3 of that 2/3, which is this light blue section. So once we have done that and we count how many squares are light blue, we have 1, 2, 3, 4 is going to be our numerator. And what will our denominator be? Well, we count up all of the squares. So we have 3, 6, 9. So my denominator is 9. So 2/3 of 2/3 is 4/9. Now, let's take a look at the questions that we have here at the bottom. What number sentence could we write to represent this problem? And is the product greater than or less than the factors? So let's think about what our equation would be. We could write 2/3 times 2/3, which equals 4/9. Okay. When you multiply by 2/3, you are only finding part of the other factor. So the answer should be less than 2/3. Okay, you're finding part of the other factor. So when we look at that and ask ourselves, is the product greater than or less than the factors? It should be less than. Our lesson today is titled Area Models for Fraction Multiplication. The why for this lesson is we are going to explore different ways to find fraction products, and the how is the fact that we know how to find area, so that's going to help us. So we're going to use what we know about area, which of course is going to lead to us using an area model. All right, so let's take a look at this area model. So the diagram to the right shows one way to represent 2/3 times 2/3. So what we would first like to do is look at the dimensions of the large square. The large square, of course, is going to be this whole square. And they're asking us what the dimensions are, basically. So blank unit by blank unit. So we have 1 unit, by 1 unit. So we're going to fill that in, 1 unit by 1 unit. Now, looking at that next question, what is the area of the large square? Well, we know to find area of a rectangle, it's length times width. So we're going to take the length times the width. So length times width, 1 times 1. My area is 1 square unit. Now, what are the dimensions of the shaded rectangle? So what we're going to do is start down at the bottom at our 0, and we're going to go up, and we're going to fill this in with 1/3, and we're going to place 2/3 here. We're going to do the same thing down at the bottom because this was divided into thirds. Now, when we look at the next question, it asks us, what are the dimensions of the shaded rectangle? So we're going to look here. This length right here is 2/3, and right here is 2/3. So our dimensions, it's going to be 2/3 of a unit by 2/3 of a unit. We're then going to take a look at the next question. What is the area of the shaded rectangle? So we're going to count. We have 1, 2, 3, 4 shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are going to write 4/9 of a square unit. The next question asks us to write a multiplication number sentence for the area of that shaded rectangle. So we would then write 2/3 times 2/3 equals 4/9. So let's take a look at another example. So on this particular area model, they're asking us to label the tick marks on the number lines first. So for us to do that, we're going to look at how many squares we have. So this is we're gonna start at the 0, so this would be 1/4, 2/4, 3/4. And then we're going to do the same thing at the bottom. 1/4, 2/4, 3/4. We're then going to go to letter B. What are the dimensions of the shaded rectangle, blank unit by blank unit? It's going to be 1/4 of a unit by 3/4 of a unit. So if you're wondering where I got those fractions from, this is only one column here. So this is where the 1/4 came from. And the fact that we have 3 of those, we land on 3/4. So what is the area of the shaded rectangle? When we look at letter C, it says hint. The area of the big square is 1 square unit. So if we count the squares here, this is 1, 2, 3. All the squares we count, there are a total of 16. So our area is going to be 3/16 square units. Letter D asks us to write a multiplication number sentence for the area of the shaded rectangle. So we would write 1/4 times 3/4 equals 3/16. So we're going to go ahead and do one more example. Once again, we're going to label the tick marks on the number lines. So as we look at those, we have 4 squares once again, so we are going to label with 4 as our denominator. So 1/4, 2/4, 3/4, and again on the bottom, 1/4, 2/4. Ooh, this one is not fourths. So what do we have there? We have thirds. So we're going to change that. So this will be 1/3, 2/3. All right, that changes things just a little bit there. Okay, we're going to look at what are the dimensions of the shaded rectangle. So we look across the bottom, we have 2/3. Go up on the left side, we have 2/4. So we're going to have 2/3 by 2/4. What is the area of the shaded rectangle? The area of the big square is 1 square unit, once again. So we're going to look here and count. 1, 2, 3, 4. 4 squares are shaded out of 12. So we have 4/12. And our multiplication number sentence for the last part is going to be 2/3 times 2/4 equals 4/12. So let's summarize what we've done today. We learned that we can use our knowledge of area to model multiplication of fractions. And basically, we are multiplying length times width, just like we would if it were a rectangle. So keep juggling those balls, guys. Until next time.